Alright guys, today we're working on radians and arc length. Radians are just another way to measure angles. We've been using degrees the whole time. There's also another measure called radians, which we're going to introduce you to today. First of all, these are based on circular functions, so we're going to be using a circle a lot. And to make things easier at first, we're going to use what is called the unit circle. And unit circle just means a circle that has a radius 1. If you look at the little pink line there, the radius is 1. And we're going to use points on the circle. Every point on the circle, if you measure the distance from there to the origin, it's going to be 1. So the radius is going to be 1 for our unit circle. But it's going to be much easier to learn what I want to teach you using a unit circle. Now, please understand, it does not matter how big a circle is, what the radius is. These things will still work, and they're all still true. But it's easier to learn the first time just looking at the unit circle. So let's go from there. Black slide. Okay. One thing you need to know real quick, the circumference, you can remember from geometry, the circumference of a circle is 2 pi r. And if, so that pink line you see is all the way around the circle, because we're using a circle with radius 1, the circumference of our circles are going to be 2 pi times 1, which is just 2 pi. So the length, the distance around this whole circle, or the length of the arc, remember it's called an arc from geometry, that arc all around a circle is 2 pi long. And if that's the case, then if you look down here at the bottom, if the whole circle is 2 pi, if you go halfway around a circle, like they did here, it's just 1 pi, because that's half of the circumference, just 1 pi halfway around. So let's review real quick. 2 pi is the arc length all the way around the circle because of 2 pi r, and because we're using a circle of radius 1. And pi is halfway around because we're using radius 1. We can keep going. If that's the case, then that little pink arc you see right there is pi over 4, or you could think of it this way. It's 1/4 of the way to pi. You know, pi is halfway around. You know, pi is all the way to there, so 1/4 of it is pi divided by 4. One more picture here. Pi over 3, 1/3 of the way to pi looks like that. Remember, pi is halfway around. Keep saying that. Pi is halfway around because 2 pi is all the way around. And so 1/3 pi, or pi over 3, is 1/3 of the way to pi. Remember, this is pi right here. If you go all the way around, you got the 2 pi. Last one of these I promise, just a few more. Pi over 2 is halfway to pi. Remember again, over here, that's pi. So halfway to pi, pi over 2. Look at the other one right here. Pi over 6, you guessed it, 1/6 of the way to pi. Pi's over there, so 1/6 of the way to pi. Keep looking more. 3 pi over 4, that's hard to read, it's kind of blurry. 3 pi over 4 means 3/4 of the way to pi. These are great pictures, by the way. I hope this is making some good sense to you. And the last one I have here is 5 pi over 3, which really, if you think about it, 5/3 is 1 2/3 pi. So what happens is they went to 1 pi, and then went 2/3 of another pi, which is almost back around to where you started, almost to 2 pi. Not quite 2 pi, but it does put you in quadrant 4 down there. You went almost all the way around 1 2/3 pi. So those are really good pictures and good examples right there. And if you understand that, you're going to be a good head start to getting radians here in just a second. Okay, here's the definition of a radian. 1 radian, and we're talking about the angle here. A radian measures an angle, measures this angle right here. And we're going to use theta like we always have. 1 radian is when your arc length, right here, the pink part, is equal to the radius. Okay, so in our case, if the arc length is 1 and the radius is 1, that angle that forms that is 1 radian. 1 radian, no more degrees, 1 radian, if that's the case. One more time. If the arc length equals the radius, it's 1 radian. So what if I went 2 times? What if I went all over here? 2 times the arc length. Well, that angle, if I did this, that would be 2 radians because I went twice as big as the radius. It's always arc length. We're going to use S for arc length a lot over the radius. That tells you how many radians it is. You take that arc, divide it by the radius. Okay, here's some pictures, more pictures. First of all, 1 radian is about 57.3 degrees. That's just kind of take it or leave it. It's about almost 60 degrees. I just drew this one. Here's 2 radians because what happens here is that arc length, the pink arc length, is twice as big as radius. You can see the angle right here. You know, theta would be that angle right there. And because the arc length is twice as big as the radius, that's 2 radians. Like another one. 3 radians is almost all the way to halfway around the circle, almost the way to, oh gosh, think about this. It's almost to pi. You know what pi is? Remember pi was right here? Guess what pi is? Pi is 3.14. 3 radians almost to pi. That's kind of crazy. That's because it's arc length, which is 3, over the radius, which is 1. 3 arc lengths. Here's the angle again. 3 arc lengths. 3 arc lengths over 1 radius. 3 radians. And 6 radians is almost all the way around the whole circle. And I wonder why. Mainly because this point, right, remember that's 1 pi right there, which means that's 2 pi. 2 pi, you would do 2 times 3.14, which is 6.28. So it is almost just barely over 6 radians. And again, because remember, arc length over radius, the arc length, there's 6 ones. Here's the angle, and the angle I'm looking at is that. It's that whole angle right there. It's a huge angle. The angle there is 6 arc lengths over a radius of 1, so it's 6 radians. 6 radians arc length over the radius. So it is 2 pi radians all the way around the circle. It is 1 pi radians halfway around the circle. Okay, the math work you're going to do today is going to make you convert between degrees and radians, so you can kind of get a feel of, kind of how they're related to each other. And here's a huge thing up here on top. Man, you need to get this down. Pi radians is, same thing as 180 degrees. 180 degrees, same thing as pi radians. So if you divide those two, you're going to get 1 because they're the same thing. 180 degrees, pi radians mean the same. That's the same measure. 180 and pi, same measure. 180 and pi. So knowing that, we can convert from degree to radians just by multiplying by pi over 180, or pi radians over 180. And we can go the other way, radian to degrees, by doing 180 divided by pi radians. And you won't have to think a whole lot about which one to use, because we need our measures to cancel. Let me show what I'm talking about here. 2 more slides. We're there, almost there. Hang in. All right. First one, convert each to radians. So they're going to give me degrees here. In this first example, they gave me 120 degrees. So what I did is I put 120 degrees, and I thought about what I had on the last slide. It said you multiply that by pi over 180. And here's why. If I put pi radians over 180 degrees, what happens is my degrees cancel. So all I have to do is multiply 120. Well, this time I did this. Because 120 and 180 cancel each other, like 60 goes in there 2 times and goes in there 3 times, I just wrote it like that. I put 2 pi over 3 radians. Technically, it wouldn't be wrong if you multiplied by the pi, but you need to get kind of the habit of things will cancel. We're just going to cancel those and leave them in there, leave the pi in the answer. Now, the second part of this, they gave me one with a decimal in it. I'm doing the same thing. I forgot to write the radians here. That should be pi radians. But what happens again is my degrees cancel, and this time 297.25 and 180 do not cancel. So I just actually did the multiplication on my calculator. By the way, your pi button is right on top of your exponent button on your calculator. And I just punched it in. I punched in the top verse. I punched in negative 297.25 times pi, divided that answer by 180, and got negative 5.19 radians. So you might want to practice that on your calculator real fast. Stop the video and check it out. And the last thing, they'll make you go backwards. They're going to say, okay, let's convert radians to degrees. So they give me these radians. Now, again, I forgot radians. That's radians. And this is, remember, pi is radians. So what I need to happen here is I need my radians to cancel, which they do. And this time I knew that 4 goes into 180, and it goes in there like 45 times. So I just did 3 times 1. Sorry, the pi's cancel also. So just 3 times 45 and got 135. And your calculator will do that for you if you want it to. One more, they gave me 8.5 radians, no pi in it. You don't have to have a pi in radians, but a lot of times they do. So I did this, my radians cancel, and then I just punched it straight in the calculator. 8.5 times 180, divided by pi. Remember the pi button's right above your exponent button, and got 47.01 degrees. And we're going to stop there for today, and tomorrow we'll work on making sure you understand the unit circle and how to measure arc lengths and exactly what a radian is, and then converting them from degrees to radians. And we'll work on the rest of it the next day. So I hope it wasn't too bad. Rewatch if you need to. Take some really good notes, and I'll see you tomorrow.